Okay, again, previously we tried to differentiate what is precision and accuracy. So accuracy is always comparing your measurement to the accepted value. And precision only means, well, not necessarily you have to compare it with the accepted value, but you're just comparing all the measurements that you have. If they're very close to one another, you would say that it's precise. And if not, well, they're not precise. So let's take example number two here. Marlo is measuring his weight with a weight scale. The first four trials are shown below. So first trial is 350, 370, 365, and 360. So the question is, if Marlo's actual weight is 420 newtons, what are these measurements? Accurate or precise? So this one here, you would take this one as your accepted value. So all of the trials given are your measurements. Okay. So to answer this question, maybe perhaps to have a good gauge, we can get the average or just the mean of all these measurements. So the mean is just 350 plus 370 plus 365 plus 360 all over 4. That's how you get the average. And this gives you a value of, well, kindly check. This is just around 360 newtons. Okay. So the average of all this measurement is 360 newtons. And uh, the actual weight is around 420 newtons. So based on this result, what can you say? Is it accurate or precise? Anyone?
Not accurate, not precise.
Not accurate, not precise. Okay. Well, maybe you can have a case since of the values. Maybe, although I cannot blame you also that when you say that it's not precise, but in certain level, if you can see the average is 360, and if you're going to compare all the values, maybe perhaps they are close to one another, given that the values that you have is also in the hundreds, right? And the difference is around maybe 10. Okay, so you have several hundreds the values. So I would say, again, I would also not cannot blame you if you will say that it's not precise. So maybe in this case, I would say that just looking at the values here, I would say that uh, precise, but not necessarily accurate. Okay. Again, this is just basing on my average and comparing it with all of individually. So maybe the difference is around 10. Well, less than 10 by average, the difference of the values. And then dividing it with the average, I think I would get a smaller uh, uh, difference, percent difference for that. But again, I would not also cannot blame you if you'll not say if you will say that it's not precise. There some sort they are spread out from 350 to 370. Okay, but how do we decide? Well, in this particular case, we don't have a basis for that. We just try to look at the values. At least we get the average also here. So we will try to use what we call errors. Okay. So in science, in general, errors are not mistakes. Okay. So these are not mistakes. So errors in science are just a way of expressing your uncertainty and accuracy of measurements. And again, this is due to the fact that you cannot have a perfect instrument used to measure, because all measuring instruments have a level of accuracy and precision. That is why always when doing an experiment, you will try to express the error. Okay. And the error that we'll be dealing with here is an error called absolute error. So the absolute error is just measured or computed as the difference. So you just take the absolute value of your measured minus the accepted. So the accepted value is again just the usually that you can see in tables. Okay. It's given in a particular experiment, and measured is the one that is a result from your measurements. And the percent error is given as, if you can see here, this is just the absolute error essentially. This whole thing, this is just the absolute error. Absolute error divided by the accepted times 100%. So at least with the percent error, you have a good sense of the accuracy of your measurement. The usual case is if you really want, uh, this is just conventionally. Conventionally, in your experiment, you need to aim for a percent error of less than 5%. So less than 5% error, that would entail a good good result. Okay, not greater than 5%. So less than 5%, that's good good result. Okay, so again, the absolute error is just the difference between the measured. If you can see here, that's absolute value, so you disregard uh, uh, the negative sign, because your accepted value can be higher or lower than your measured value. So essentially, when you're talking about percent error using this particular uh, equation, you will not get a negative value. Okay, so in our case, we just use this particular way of expressing your error, the percent error. So let's take an example here. Marlo's hat has a mass of 30.10 grams. When he places his hat on a balance, the balance reads 30.95 grams. What is the percent error in the balance reading of the Marlo's hat? So we want to get the percent error. So I think this is what you've also done in your other subjects. So you always start with what you have. So identify the things that you have. So 30.10. So what do you think is this mass here? So percent error, if you can see, there are, it just involves two quantities, the measured and the accepted. So you need to know what would be the measured in order for you to solve percent error, and the accepted. Although in this case, it doesn't necessarily, uh, in a sense, when you try to compute, it doesn't really affect the final result. But it's also good for you to identify which is which. So what is that 30.10 grams? Is it the accepted or the measured? Anyone? 30.10. Is that your measured or is that your accepted?
I put that it's the accepted.
Okay, great. So that would be your accepted. because you are being given that maybe this is from the manufacturer, that yeah, usually you can see not only the dimensions. In some cases you'll get the net weight, or yeah, the weight of all the weight. I would not use the term weight, because weight is a different quantity with mass. Okay, but anyway, it's just that in layman's term we try to interchange mass and weight. But yeah, that would be the accepted value. And well, obviously the other one would be your measured value. So you're gonna take note of that. That is 30.95 grams. And that would be that. And then I'm going for the percent error. So percent error is my question mark. So percent error, I just gonna copy for my solution. So always start with the formula that you know of. It's just good to write it first. So measured minus the accepted, all over the accepted, and then times 100%. Okay, so now this is where I'm gonna substitute my values. So the measured value would be 30.95 subtracted with the accepted value of 30.10 divided by, okay, yeah, it matters if you somehow interchange these two values. Maybe the absolute error will give you the same value. However, when you try to get the percent error, remember, it would be divided by the accepted value. And if somehow you interchange these two values here, for sure, you'll get a different value for the percent error. So percent error, therefore, is, if you can see, this would be around, well, if I gonna take note of the correct sig figs, well, the numerator involves subtraction. So that means that I gonna be cutting off up to the hundredths place, okay? Because I'm subtracting. And then after subtracting, this is now division. So in division, remember that you need to take note of the significant figures. This is 2 sig figs, and this has 4 sig figs. Okay, so the final answer, if you're dividing, taking into account the correct number of sig figs, the final answer, if you are dividing, it should be in the least number of sig figs. So it's not to the number of decimal places, it's the number of significant figures. That is that is why when you try to divide this one, it should give you a value of 2.8 percent. So if you can see, this is 2 sig figs. So you have 2 sig figs. That's the final answer. Okay, it's not 2 decimal places because you're dividing. The final process is division. So the final answer is 2.8 percent. And actually, that is a good result. That's less than 5%. So for our case, like for just experiments that we will be doing, that's a very good result. 2.8% as a percent error. So any questions? Any questions with this one? So You just have to take note of the measured, well, from the word measured. So usually it's the measurement that you do in the experiment. Accepted value is the one that is given to you. Okay. Usually, again, it's given in a table or from the manufacturer itself that this is the actual. Okay. So, okay, that ends our discussion for 1.2.